So, hi, my name is Alexis Taylor.
I'm David Silva.
I'm Artemio Trevino.
And we are Group 2. So, the problem that we were given for Part A was using the definition of the derivative, determine f prime of x for the function f of x equals the cube root of x. To begin this problem, we must identify what the definition of a derivative is. The derivative of y with respect to x is defined as the change in y over the change in x, as the distance between x0 and x1 become infinitely small. In mathematical terms, f prime of x equals the limit of f of x plus h minus f of x all over h, as h goes to 0. That is, as the distance between the two x points, h becomes closer to 0. The slope of the line between them comes closer to resembling a tangent line. Since f of x equals the cube root of x, we are going to plug that function into the derivative equation, which is shown here. And then we're going to use the difference of cubes, which is a form of 1 for the cube root, which is also known as a conjugate, to further explain and to further solve this problem. Okay, so the equation for the difference of cubes is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And for our specific equation, a is going to represent the cube root of x minus h, and b is going to represent the cube root of x. Okay, so this is the equation shown with the difference of cube root conjugate. And once the equation is multiplied out, we are left with this, and we're left with an h variable in the numerator and the denominator that can be canceled out, which is shown here. And then once those two variables are canceled out, this is what we're left with.
Cool.
So this is a simplified version of the function, and we're going to look at the limit as h approaches 0. Now, since we have seen what the function does as h approaches 0, we are going to simplify the function. And this is what the simplified version of the limit is. We have now solved the first half of our problem, and we did this by using the definition of the derivative and the difference of cube root conjugate. And we now know that the derivative of the cube root of x is 1 over 3 times the cube root of x squared.
For part 2, it says determine the constants of a and b such that as the limit approaches x approaches 0, we have the cube root of ax plus b minus 2 all divided by x equals 5/4. So the first thing we're going to do is use common sense. So we know that we're gonna let x approach 0. So by doing that, we're gonna place 0 where x is. As we plug that in, we're going to try and simplify it a bit. And as we get here, we get the cube root of b minus 2 divided by 0 equals 5/4. But usually when we see stuff like this, when we see a 0 on a bond, we'll say that it's usually about to blow up. So usually in basic problems, when we have stuff over 0, we usually know that it blows up. But in this situation, we already know the limit is 5/4. So by knowing that, we know that the function is close to something around 0. So the best thing to do would be to plug cube root of b minus 2 instead the numerator, which is taking the numerator, instead equals to 0. Like for example, we see this little problem over here. We see that the function is 0.005 divided by 0.001. And since we know which both of these numbers on the numerator and denominator are close to 0, we know that x equals 5. So the next thing we're going to do, as I stated, is set the numerator equal to 0 and try to solve for b. Go. So now, like I stated, we set the numerator equal to 0. So now let's try to solve for b. So the first thing we're going to do, basic math, we're going to add both sides to 2, which will get us just the cube root of b equals 2. So next, set it, to get rid of the cube root of b, we set it to the power of 3, both sides to the power of 3. Cancels out the cube root. We'll set cube root of b to the 3rd power and set 2 to the 3rd power. That'll get rid of the cube root, it would just be b, and that would just create 8. So now we know that our constant for b, the number for our constant b is 8. So that's how we find b.
All right, so now that David has found b for us, now it's my turn to find a for the problem. So to begin this, we will use the b that he found for us. So we'll set up the problem to be cube root of ax plus 8 minus 2 over x. So now we're going to do the difference of cubes. So I'm going to write that on the board right now. All right, so now we're going to multiply this across. So like normal distribution over multiplication. So we get And once you simplify everything across, we can now start to eliminate certain things in the numerator that cancel out. So once we do all that, you are left with, let's see, what was x a all over x times 8x plus 8 is 2 8x plus 8 plus 4. So now with this one, we know that we can factor out an x. So this will be a form of 1. So then we would get left with a over, let's see, cube root of ax plus 8 squared plus 2 cube root ax plus 8 plus 4. So sorry for the mess, but so now once we simplify all this down, we get a over the cube root of ax plus 8 squared plus 2 times the cube root of ax plus 8 plus 4. Now that we have simplified it all down, we can now revert back to finding the limit now that we have simplified it. So for this one, we're gonna for the limit of this, we're gonna let x approach 0. So we're technically gonna plug in 0 in for x, which is not really 0, it's just something close to 0. So we have a over the cube root of ax plus 8 squared plus 2 times the cube root of ax plus 8 plus 4 is equal to 5/4. So if we let x approach 0, we can plug in 0 right now. We get a over 3 cube root of a times 0 plus 8 plus 2 times the cube root of a times 0 plus 8 plus 4 equal to 0 again. So we know that anything times 0 is just going to be 0. So those are going to just disappear, as you can see. The next step, we go down, we have a over, as we see, we got rid of these a times zeros. So we have the cube root of 8 squared plus 2 times the cube root of 8 plus 4 equal to 0. And if you know, the cube root of 8 is 2 squared is 4, so that's where we get this term for. Again, cube root of 8 is 2 times 2, you got 4, plus the 4, we just brought that down. So we got a over 4 plus 4 plus 4, set equal to 5/4, which this all adds up to 12. So we got a over 12 is equal to 5/4. So basic thing to do now is to get a by itself. So to do that, we're going to multiply 12 across both sides to get rid of that numerator or the denominator. And once we do that, we'll be able to simplify and find a. All right, now to continue where we left off, we had a over 12 equal to 5/4. So this is basic algebra right here. We're just going to multiply 12 across the board. So we got 12 over 1 times 12 over 1. This is a form of 1, so we just get left with a equal to 5/4 times 12. This can be reduced down to 1 and 3. So you get left with 15. So we have now solved our second problem. A is equal to 15 and B is equal to 8. So we have found the constants that make this true because the problem said determine the constants A and B that make this limit true. So we got it. It's all done. All right, so this concludes our project presentation. The overall gist of this that I can describe to you in a conclusion of the problem is that it's not hard work. If this was, if using the definition of derivative was hard, hopefully I explained it better for you now. Most people know how to use the shortcut to find this exact answer. But using the definition of derivative and using the difference of cubes, which is a way that you can use a conjugate of a cubic root to get that cube out of the numerator, as you can see that we had a problem with. By using the difference of cubes and the definition of a derivative, we were able to find that the derivative of our f of x equals cube root of x is 1 over 3 times the cube root of x squared. And then for project 2, we pretty much carried on that same topic of the difference of cubes using it as a conjugate, because we had a cubic root here, and by using the difference of cubes, we were able to use that form of 1 to kind of cross multiply and to use that to eliminate some of our variables. And the key component was trying to solve b first, so we wouldn't have two different variables running around. So when David explained that to find b, once I found b, I was able to plug that in and make it a little bit easier in finding a. But once again, you got to use the definition of a derivative for the number 1. That's the basic gist of that one. And understanding that for a cubic root, you must use the difference of cubes to get that cubic root out. And for part 2, it was pretty much the same gist of knowledge of understanding the difference of cubes and using that in your favor to help you simplify it. And the answer for number 1 was f prime of x, which is the derivative of x, is equal to 1 over 3 times the cube root of x squared. And then the answer for number 2, we were told to find the constants a and b that made this such limit true. So we got the answers as a equals 15, b equals 8. So we're all done. I hope you learned a lot today, and I hope this will help you down the road.